And it is this pricing formula that will be in the spotlight of this lesson, especially with the focus on these guys over here, because as you can observe, these are the only values that are not directly given as inputs. So the first step is to calculate the values of D1 and D2. And as you can see on the screen, all the necessary inputs are already provided. So if we plug in the values, we would get this value for D1 and this value for D2. So now let me map these values on the two bell curves. Now, of course, these are standard normal distributions with a mean of 0. And in the case of the call option, we plot D1 to be somewhere over here, and we plot D2 to be somewhere over here. Now, in the case of the put option, we use negative D1 and negative D2, and negative D1 would be somewhere over here, while negative D2 would be somewhere over here. And basically, ND2 is nothing more but the area under the curve from -infinity up to D2. And if we use statistical tables, we will find that ND2 equals to approximately 43%. And it is this value that will be used in the option pricing formula. And what I want you to be aware of is that this value is representing the risk-neutral probability that the call expires in the money. Now, ND1 follows the very same logic because this one represents the area under the curve from -infinity up to D1. And if we look it up in the statistical table, ND1 is approximately this value over here, and it is this value that we will end up using in the call pricing formula. And another important point that I want you to be aware of is that ND1 is basically the delta of this call.